Hello again. In this lesson, we're going to look at estimating the gradient of a curve at a given point. So we have two graphs here. Both are distance time graphs, where time goes along the x-axis and the distance is on the y-axis. So what we can see here, this graph is showing us that we have a build-up of speed, slowly gaining in pace, going up the graph. Same with this one here. So we're going to estimate the gradient of the curve. Well, if you think back to gradients, that sounds a little bit odd because gradients normally are from straight lines. So if we have a straight line, to find that gradient, what we do is we work out the change in height from the one point to the next and divide that by the change in distance from that same point to the next. So if this is point 1 and this is point 2, we are looking at the height from point 1 to 2 and the distance from point 1 to 2, and the gradient known as m is equal to the change in the height divided by the change in the distance. How do we apply this to a curve? Well, you're talking about the change at a given point. We get told at what point we want to work out the gradient. So in this case, let's work out the gradient at 3 seconds. So what we do is we put a point there, and then we draw a tangent to that curve at that point. So here we have a straight line at a tangent to the curve at this point here. And now what we do is we work out the gradient of this straight line. So I draw a triangle, that's a right angle. Distance travelled along the x-axis is 2 seconds. Now what I need to do is figure out this height from this point here all the way to this point here. So that's the height I'm looking for. So I can see that goes from 0.3 all the way to around about 3.7. And again, they are approximate, hence the reason for the word estimate. 3.7 minus 0.3, and that gives us 3.4. So now our gradient for this curve is equal to the change in the height, the change in y, which is 3.4, that's in meters, divided by the change in the time, which is 2 seconds. If we do that, we get 1.7 meters per second. If this was a person walking or moving, we can see that their speed at that point was 1.7 meters per second. So you can visualize that. Every second they can move a distance of 1.7 meters. Let's do another one. So let's choose a different point. In this case, I'm going to choose this point here. So again, I draw a straight line through that point. I think one of the key things here is try and give yourself a decent length of line. So back to our next step, that is to draw a triangle like we did before. I can see this is going through the point of 1, so I'll use that there. The triangle is going to go from 1, and I'll take it to 4. I don't have to do it this way. I can put it anywhere I choose, but I can just see that actually it's quite convenient going from this point here to that point there. I can see therefore I'm dividing by 1, 2, 3. So I can see that that time travelled was 3 seconds, and the distance goes from 0 to here, which is around about at 1.7. So now our gradient, the change in y, divided by the change in x. All we do here is the 1.7 divided by 3, and that gives us 0.57 to 2 decimal places, and that is meters per second, and again that's to 2 dp. So what does that actually mean? So we can see at this point on the graph, that's a person walking. At this point on the graph, they are walking just under 0.6 meters every second. So they've probably started off fairly slow here, but by the time they've got to here, they've got some momentum going and they're walking at a faster pace at 1.7 meters per second. So we're looking at something called the rates of change. We're going from a speed of 0.57 and the change is increasing to a speed of 1.7. This is how we estimate the gradient of a curve at a given point. As always, thank you for watching, and if you've got something out of this, please like and subscribe.